All right, 3.4, modeling trinomials as binomial products. Okay, so binomial products, those are dealing with being in factored form, right? The product of factors, product of binomials, is how we're writing it. So we're going to do some modeling. And before we get there, though, I want to show you how this works with just numbers. So 13 times 15. No calculator. What are some ways you might break this up? Now, one of the ways that I'm going to show you is the area method. I'll show you this because it works for binomials when we get down here, and it's a good strategy overall. So instead of 13 times 15, I'm going to look at it as 10 plus 3 times 15, oh, sorry, not 15, times 10 plus 5. All right, and it's area method, so I am going to draw a rectangle. Now along the side here, I'm going to write 10 plus 3, and over here, 10 plus 5. And I'm going to split it up right here. You know what, I suppose on this side, I should kind of write it as 10 plus 3. So I'm going to find the area of this rectangle. To find the area of the rectangle, I would multiply it by its side lengths. So this is 10 times 10, which is 100. And then this box right beside it, that would be 10 times 5, which is 50. Same thing for these bottom boxes. I have 3 times 10, so that is 30. And this one here, 3 times 5, so it's 15. So this might even be reminiscent of a Punnett square as well. All right, and finding the areas here. So that is step 1. To finish it off, I'm going to add these all together because it's 100 plus 50 plus 30 plus 15. So I end up with 100, 50 plus 30, 80, plus 1, 195. Should be 13 times 15. So that's how we can solve it. Of course, you would just use your calculator right now. But we can't do that when we have x's in here. So let's look at this binomial multiplication. We're going to do the exact same process, just with x's instead of just numbers. So x minus 3 and 2x plus 1, drawing my rectangle here, and splitting it off. All right, so let me make this a bit neater actually. X and minus 3. So I've got my x here, my 2x here, and I'm multiplying them together. So I have x times 2x, which is going to give me 2x squared. X times 1, which is just going to give me 1x, or x. 2x times negative 3. Well, that was going to give me negative 6x, right? Negative 3 times 2, negative 6, and then the x is just along for the ride. And negative 3 times 1 is just negative 3. And now I add these all together. 2x squared plus x minus 6x minus 3. And I can combine these like terms. So I have 2x squared minus 5x minus 3. And that would be my expanded answer after I do my binomial multiplication. All right, so that is the area method. This is my more a manipulated way of doing it. More, it's a diagram, there's a bit of a picture of the rectangle. But I can do this just algebraically, the mathy way, with what we call the distributive property. Now, we often also call this FOIL as an acronym because you do first, outer, inner, last is what that stands for. What this means is first, my outer. So I'm going to multiply x times 2x, and then I'm going to multiply it by this one as well, plus x times 1 plus negative 3 times 2x, right, my inner last, plus negative 3 times 1. All right, well, let's do this multiplication. X times 2x, that's 2x squared, plus x times 1, that's just x, plus negative 3 times 2x, minus 6x, and plus negative 3 times 1, that's negative 3. Again, I group my like terms, and since it's the same question, I'm of course going to get the same answer. So 2x squared minus 5x minus 3. Notice I've essentially done the same thing, right? All of these little multiplication steps, that's what I do inside these boxes. And then I'm adding them all together like I do here, combining my like terms and getting the same answer. So whether I do the area method or the distributive property, whichever works is what you're going to do. Area method is good when we're starting out, but I do want to encourage you to start working towards doing the distributive property more, especially in future math classes. It's just a little bit cleaner, and it does lend itself a little bit better to when we start talking about factoring, even a little bit later in this chapter. So that is a good one to build towards, but right now, if the area method's the way to go, keep doing that. Okay, so let's expand this one here, and I am going to do it with the distributive property. So like I said before, it's good to start working towards that. The more we see it, the better that is. If you need to do the area method, pause the video, do that first, then hit play and look at the distributive property with me as well. So I'm going to do first, inner, outer, last. So you're multiplying each thing here by both terms in the other brackets. So I have x times x plus x times negative 4y. And then here, plus my inner negative 2y times x plus negative 2y times negative 4y. Right, so I have two different variables here. I've got x's and y's. That doesn't matter. Just remember when you're combining variables, so combining exponents, I can only do that with the same variable. So what I mean by that, x times x, they are the same, so I get an x squared. All right, so now I've got negative 4y times x. Well, none of those things are the same. I've got a number, an x, and a y, so I can't really do anything. I just have negative 4xy. Same with this, negative 2y and x. I can't really do anything with those, so I just have negative 2xy. And here, my negative 2 times negative 4, I get positive 8, and y times y, I get y squared. All right, so now you may be wondering, this one here, I wrote them in the same order, right? X before y. In math, just like in English, there's an order to things, and we follow the alphabetical order. So whenever you have two variables, always write them in alphabetical order. So this is proper negative 4xy. Negative 4yx, while technically correct, is not proper. Right? It should be negative 4xy. My variables are in alphabetical order. I know, math has so many rules, doesn't it? All right, but anyways, we're almost done. We just need to combine those like terms that I underlined. So my x squared stays out here. Negative 4 and a negative 2, that becomes more negative. So negative 6xy plus 8y squared. So whichever way you did it, if you did area method or you did by distribution property, this is the answer that you should be getting. All right, and our last example here, if we have a binomial and a trinomial. Okay, so bi means 2, tri means 3, right? A bicycle has 2 wheels, a tricycle has 3 wheels. So a binomial has 2 terms, a trinomial has 1, 2, 3 terms. So just like before, when we did binomial times binomial, same process to do it by a trinomial or larger. It's just more terms. It's just those more steps. But if I write it again down here, x plus 2, 2x squared minus 5x plus 1. Going through it again, and honestly, I'm a math teacher, and all the way through university, I did my distributive arrows. I showed this because every time I didn't, I forgot a term. So I've used, as you're doing this, to show that you're multiplying, that this x is going into each of these terms. All right, so x times 2x squared plus x times 5x plus x times 1. Now, as you're getting a little bit more comfortable with this, I'm okay if you start skipping writing this step, but that's once you're getting comfortable. Right? So don't skip steps too soon. And this one here, everyone gets an arrow. So plus 2 times 2x squared plus 2 times negative 5x. Careful here that you aren't losing signs, especially those negative signs. Those are indeed important. All right, so I did all of my multiplication now. Now I just have to actually do it. So x times 2x squared, I'm going to get 2x cubed plus x times 5x, 5x squared plus x times 1, that's just x, plus 2 times 2x squared. 2 times 2 is 4, and the x squared. 2 times negative 5x. Well, 2 times negative 5, negative 10x. And plus 2 times 1, well, that is just 2. Right. And now, finishing it up, I group my like terms. So my 5x squared and 4x squared. So 2x cubed plus, well, 5 plus 4, 9x squared. Then I've got plus x minus 10x, that's minus 9x plus 2. Now you may be tempted to go further, but we can't. We have fully simplified this. This would be the fully expanded form, and we would be done. Right, so that's our distributive property. I have lots of space, so I'm going to do it in the area method too, in case you're wondering how this would look with the more terms. It's the same, it's just more. Right, so x plus 2, 2x squared minus 5x plus 1. Right, 2x x squared times x, that's 2x cubed. X times negative 5x, that's negative 5x squared. Oh, and you know what? It's a good thing that I did that, right? Negative 5x squared. Look what I did. I was talking about how you can't lose signs, and I lost a sign. Negative 5x squared. This here should actually be a negative, which is going to change my answer here. I hope you caught that in your work while you're watching this video with me. So I have negative 5x squared plus 4x squared. So I actually have a negative 1x squared. Right? And that's because this negative sign here I lost. So we got to be careful with those negative signs. But continuing on, x times 1 is x. Now 2x squared times 2, 4x squared. 2 times negative 5x squared, negative 10x, and 2 times 1 is 2. Now the same idea, I add up all of these, 2x cubed minus 5x squared plus x plus 4x squared minus 10x, and plus 2. Grouping my like terms, 2x cubed, my x squareds, negative 5x squared plus 4x squared, negative x squared, plus 1x minus 10x minus 9x, and plus 2. So again, whichever way we did it, as long as we were very careful and didn't lose a sign like I almost did, we get the same answer. Whichever way you like the most, I'm totally okay if that's how you do it. All right, so that's it for this lesson. Binomial distribution, area method. We are multiplying polynomials, typically two binomials, but occasionally, like in this question, a binomial times a trinomial as well is the exact same steps. All right, so make sure you're practicing this. You're looking at factoring coming up really soon. Having a bit of a good base with these questions here is really going to help you feel more confident when we're factoring. All right, as always, if you have questions, please ask and show your work, do the work, and you'll be golden.